let's take a look at multiplication of whole numbers with our lesson today. We'll begin with the expression 258 times 24. As we've talked about in the past, we want to really see this multiplication sign as seeing it's the word of. It's asking for 258 groups of 24. How much would that be? How many individual? If we had 24 wins per season and we played 258 seasons, how many total wins would we have? How many of that 24, whatever it is, if we had 258 of them, how many would you have? One other thing about multiplication, and it can be helpful as we're solving multiplication problems, is because of the commutative property, it doesn't really matter the order. This is the equal to 24 times 258. So while that may be, or how that might be helpful, is when it comes time to set it up. So we're going to use the standard algorithm to solve our problem today. Let me get rid of some of this. First thing we're going to do is we're going to write our largest number on top. So whichever number has the most digits, we're going to put that on top. So we'll put 258. And it's really important that as I set it up that I am lining it up with place values, so that my 8 is my 1 spot. I want that right above my 1s on the second number, and so I'll put 24, and then we're ready to go. Now, this is really a I would say a 3-step problem. So we have 2 steps of multiplication, and then we'll finish it up with some addition. So our first step is we need to multiply the ones place. We're going to multiply 200 and then 50 and then 8 times 4. So on this first row, we're going to kind of come at it and we're going to say, well, what's 8 times 4 is 32. I'm going to regroup 30, put it up here. So then 5 times 4 is 20, plus 3, we're going to get 23. We're going to regroup 200 with this one. And then 2 times 4 is 8, plus our 2, we're going to get 1,032. And what that number represents is 258 times 4. This here is the first step of our standard algorithm approach to solving whole number multiplication. The second step is we are going to now multiply 258 times 20. So let's get another color here. Since this 20 is in the 10 spot, or this 2 is in the 10 spot, it represents 20. Now to keep that number as a tens, we are going to come down here, and this is the most crucial step of the process, and we are going to put a 0 here as a placeholder 0. What it does is it pushes all of the digits to the left 1 spot to prevent. So for example, we do 8 times 6, or 8 times 2, which is 16. So keeping that in the 10 spot instead of letting it go to the 1 spot, it keeps everything pushed over the right amount of spaces. So I'm going to come up here and on my top, I'm going to just cross these out. So I had 8 times 2, which is 16. Regroup the 1. 5 times 2 is 10. We have 11 there. And then carrying a 1 there. 2 times 2 is 4. Plus 5. And now we've got the second step complete. This represents 258 times 20. Now I want to take these two partial products. I need to find the sum to find my whole answer, because right now we have a number that represents 258 times 4 and another that represents 258 times 20, as if I were to expand those two numbers on my multiplier. Now I simply add them up. 2 plus 0, I do my 1s, then my 10s, my 100s, my 1000s. My final answer is 258 times 24 would equal 6,192. So that's a look at standard algorithm multiplication. The number one mistake that's made in my experience of seeing folks or students do these is to forget this placeholder. And when we forget our placeholder 0, what it does is it throws everything off, and just to kind of let you see what you would be looking at is you would be looking at a problem that has 1,032 plus 516. And if you were to add those partial products up, you see an answer that's roughly 1/4 of the actual answer. So it's really important that we get that placeholder in there so that it makes that second step multiplying by the tens. It actually allows us to see it as multiplying by the tens. The other thing you have to be strong in is making sure that you have your basic facts down with multiplication. Any little error within these partial products, as if we were to have any kind of mathematical issue here, it's going to throw everything off when it comes to our product here. So that's a look at standard algorithm multiplication. Till next time.